Okay, so we've set up a transformation um, in ArcGIS where we have a couple of points in local coordinate system and in UTM, MGA or AMG or whatever. So both coordinates should be metric in meters. Um, so if they're in yards or in feet or something else, then we'll need to do something slightly different. But for this, we're assuming that they're both in meters, both systems are in meters, and we've got 2 points that are spread as far up, over the area as possible. So in bottom left, top right, or top left, bottom right. The points that we use to convert want to be as spread out as far as possible, okay? So what this is, what I'm showing you here is just a little bit of just a background, and then we'll get into actually using it. So in Python, I've written a class called local grid transformer, and what this does is it takes a bunch of parameters and then it sets up a transformation, and then it can convert coordinates. So it uses a little bit of matrices algebra, whatnot, to calculate a few things, and then it basically creates a transformation formula to transform the points based on the information that you provide it. So just as an example to use it, so we can set up a local grid transformer and we can pass in the parameters of the grid name, the provider, and then the UTM coordinates, easting, northing points 1 and 2, locals, easting, northing of the local points. So that local relates to that local, sorry, that UTM relates to that local. That makes sense. So then we can instantiate we've instantiated it here, and we've created this thing called LGT, and then we can do LGT setup transform. That's going to define all of the parameters and set everything that we need. And then we can just say a converted easting, converted northing for these new coordinates that we pass in, easting, northing, and we can just print them off. So if we run that, you'll see that we get the new converted coordinates, and then we can also look at the rotation of the grid and the scale. So our scale is close to 1, which is what we should expect it to be, because they're both in meters. So the distances in both grids should be the same. So we're looking for a scale that's close to 1. If the scale's way off, then something's gone awry. Okay, and this last one, what I've done is I've just fed back into the converter one of the points that we used to set up the transformation. And then I've just said, well, what's the original point minus the converted point? The original point minus the converted point. And you can see we've got 2.561111 something to the e to the minus 9 and 0. So basically, there's no difference between when we convert a point that we use to set up the grid, we get back the same points. So we've got a scale of 1, and we've got a solid transformation. So that's the nuts and bolts of it. I won't go into the maths of it. Probably not that relevant. Okay, so we have the transformer. So what I have done is I have then taken that code that I wrote in Python, and I have converted it into an executable, this application, and I've got a little batch file which then runs the executable. So you can take this folder, transformations folder, put it anywhere. Then if you take this to transform CSV and we populate it with some ID, some local easting, local northing, and a local grid name. So these are the points that we want to transform. So these are the from points, okay? And this local grid name is going to be important because the program is capable of converting multiple points with multiple grids. but that's okay. So we've got a 2 transform set of points. And the other thing that we've got is we've got the local grid transform setup. So we'll just open that. And the local grid transform setup is based on a shapefile, which I will provide. Let me just dig it out real quick. Local grid transform points. Here it is. So we have a shapefile here, local grid transform points. Which I will, which was shown in the other video, and it's basically just a template shapefile where you can enter in the UTM coordinates and the AMG coordinates, put in another bit of metadata. Then if you export that out to a CSV, then you'll get something like this. And then all we're going to do is we're going to take this and we're going to populate it in here. So we'll keep those headers just for simplicity. So we're going to put in the AMG coordinates and the local coordinates and the grid name. We can just put in the source map, but it won't use it. So we've got the 2 points that we're going to use to transform, and we've got the points that we don't know that we want to transform. So we want to transform, where have they gone? I can't see them now, hang on a second. Let me just go back here. There we go. Local grid transforms, 2 transforms. So we've got these 2 transform points, and we've got the local grid transforms. So this transformed file will just delete. And then basically, if we just run this with this file and this file within this folder, and then we run this, it's going to come up with a little CMD. And then fingers crossed, it's looped over the file. So you can see all of this here. It's looping over the file. It's given us the scale back, I think, which is 0.98, so it's close. And then you've got each line of the file that it's transforming. When you get to the end, if you've had no issues, it's just going to say nothing basically, and it's just going to say press any key to continue. If it throws some error message or some exception, then it's probably something wrong with the setup. So then if we look in our transformed, now we have the local Eastings and the AMG Easting Northings for all of them. All of the points got converted according to that grid. So we included the ID so that when we copy and paste this back into the DEO, because what we're going to do then is we're going to take these coordinates we've extracted from the report somewhere, and we are going to populate the UTM coordinates. So in a DEO object, if I've got one open, whatever, let's just look at this one for instance, you may have a bunch of local Eastings and local Northings, but we don't know what these are, so we're just going to say those ones are these ones basically, and location information, location name will be the grid name. So I don't know what this one, I think it's Kaiser or something, whatever it is. So we're going to say, oh, it was used Kaiser, and we can just say 2 point transform using map such and such page whatever, and we'll provide that map. That georectified map will be included in our dump of our documents, and we can also include the shapefile with those we can include the shapefile with the geolocated surface sample points. So if we follow the previous 2 videos in order to get as accurate setup as we can then use them. So where this is useful is if the local coordinates are listed on a table that we can extract them from, because then we only need to digitize 2 of the points to create a transformer to transform the rest. so that we don't have to digitize thousands of points. Maybe the 2-point transformation will be written somewhere like on a couple of points, or they might show it on one map or whatever. But basically what we need to do, need to find 2 points as far apart as possible on the grid that we know the eastings in the source local system and the target system. Once we've got that, we can transform all the other points in between. No problem. So we're always looking for the most efficient way of doing it. Sometimes the map might have thousands of points on it, and to digitize all of the points is going to take a long time. Sometimes we may have to do that, but wherever we can, we'll use a transformer, and we'll always make sure that we document what we're doing, so that we don't. So that we know where the information's come from and how the transformers worked. So I'll leave the video there, and hopefully this will make sense. Okay, thanks for listening.